Hey everyone. So, as we discussed in the last video, how we're gonna structure this modular ring system, FROSTCODE. So, let's see an example of this in Maya. Okay. Let me open this here. So basically, let's start with this. Just importing. I have all the things which I need, or like all the modules and all the files in one file. Okay, so I'm importing those in one file. So as you can see here, says primal constraint controls and everything I need in just one. I just need to import this command, and this imports everything. Okay, and you can even see if I just reload this imports all this for me. So basically what I'm gonna do is I'm gonna use this module. Then I have importer has everything in there. Then we have rig global, and that has globals. This is one class which I'm gonna initialize in this variable gb. And similarly I have this networker in networks. So let's import this as well, and we have initialized n. So for example, we are creating a, so let me say, yeah, so the thing is every module will have at least these, let me show it on the ipad. Yeah, we'll have this global main module name, controls, guides, and skeleton and miscellaneous. So these will be in each and every module. Just so to create these, what I have done is I've created one single um, module which has base hierarchy. So when I do this, I have to give the asset name. For example, the asset is what's cartoon, let's say cartoon. Okay, I am not able to recall any cartoon name right now. So if I create this, I have this left arm base module. Then it has sub modules, guides, controls, skeleton, and miscellaneous. So right now, if you see, each and every this thing has this data which has the asset name. Okay, this can be used later for querying stuff and all. So okay, now next thing what we'll do is, so right now it has just created these things, these main modules. Now we have to create these networks. For creating these networks, I have a script. I'll show this all the scripts just in a minute. So to create all the networks, what I'm gonna do is I'm just gonna run this create network, and here we have to give the name of the module. Okay, it doesn't need any this thing or asset name or anything like that. We just need to give the name of the module here. Okay, so if I run this, what we have here now, let's see. If I do it like this is our main one, and these are the secondary ones. Let's indent this a little bit. So these are the secondary ones, these are the main ones. So each of these modules, the base module, the sub modules, all of them have a input network and a output network. Okay, so let's see what the next step is. So after this, the thing which has to be done inside is different for each and every module. For example, I just have one module right now. I have um, created our world module, like that has world control, cog, and stuff like that. So that's from global hierarchy. So let's say it's not good to name this left arm. Let's say uh, reg global maybe. You'll need this. Let's create this once. Create network for reg global. We have everything here. Yep. Now what I'm gonna do is I'm gonna create this. So when we're creating this, I'm returning all these groups. Okay, first, second, third, fourth, and fifth. So 0 1 2 3 4. Here if I show you, I return this rig global group, guide, control, skeleton, and miscellaneous. I'm always going to follow this order because this actually makes sense, because this is the parent. Then we have our child. All the thing which are coming to the parent will go to either guides or controls. And we can see like guides are above controls, so guides, then guides are going to pass their transformation data to controls, then controls are going to pass their data to skeleton. So miscellaneous is just like, sometimes we have rigs which are like a nub surface or something like that, which can return things to up like controls, or skeleton, so it's just at the last. Okay. So yeah, so here, as you can see, I'm taking a variable in here, and when I click this and show you, so I have all these transform nodes, which is the global guides and the things like that. Now I just need to pass these into this gb.global hierarchy. Okay, if it was something else, I can just pass these. So each and every module which we are going to create will get these 5 groups always. So we just need to pass these 5 groups in this order in here, which automatically happens from this. Okay, let's just do this. Now it's gonna create, give it a second. Yeah, so now we have a world, this thing, world based guides. We have our controls, and we have the joints as well. I'll go get to the joints a little bit later. So first I have this base guide, which can be used like this and like to move and do anything with that. Then I have the first guide, which is for this control. Second guide, which is for this. Let's put 5, maybe 3 would be fine. So this is a second, a gimbal control for a world. I have just put some value here to show it clearly. Then we have cog, this setting. This is just FK right now, but we're gonna add some functionality here later, like pivot control and things like that. So let's say, yeah, so we have these guides. Okay, so what happening to the guides is like these are all connected to each other with like the world matrix of this is connected to this offset parent matrix like that. Okay, and we are transferring all the stuff in here. Where we are transferring it, let me show you one thing. We have this our rig global guide. Okay, and our control input guide. So this is output of guide and input. Let me just get here. Yeah, so as you can see, one second, what's happening to this? So we have this output here, right? We are transferring all the small guides, world matrix and world inverse matrix to this output. Okay, and we are transferring this output to the input of our controls. Okay, so what we're going to do is like we're going to have a clean um, transfer of data between these two modules, these two sub modules actually, and that's the same thing which will be between the main modules. We're going to get data in here and output data from here. Okay, so basically let me just erase all this. Yeah, so we are getting data here in the controls input network right now. Let's get back there. So out of guide to input of controls. Now what I'm doing is from this input, I'm using all these guides to control our controls. Okay, it's getting an offset parent matrix and I'm multiplying it with the parent inverse matrix of the other one, or you can say the world inverse matrix of the upper control of this control, and similarly for each and the every control. Okay, so now as you can see here, we have this guide, base guide, which controls everything, which can scale everything. Then first guide controls this, second, similarly it goes on, and we have these controls. So basically what's going to happen is the same thing is going to happen with rig skeleton as well. So we're going to output all the control data to the rig skeleton's input. So from this, our network in of I'm sorry, so the network out of controls is gonna transfer all the matrix position and stuff to the skeleton's network in. Okay, then what we're gonna do is we're gonna use these to so as I have written here, in matrices for controls network for connecting joints. So all that transformation data is gonna move all the skeleton, and this skeleton is going to drive our mesh how we normally do in the rig. So there are some things which I have done differently for these joints, which are these joints doesn't have inherit transform, and the second thing is they are all connected to offset parent matrix of all these controls. Okay, they're not like they're not just simply connected to a connection or something like that. But what I'm gonna do when we are gonna export the joints, if we ever need to, so we just do not duplicate or get a normal joint, match the transformation of these joints and parent constrain them, so we can just easily bake them with normal values and just parent them all of them under one root. Okay, so that's how this thing is gonna work. So let's see how we have written all this and how this is creating these things and matching networks and all this stuff. So let's start seeing how I have scripted this out. So basically, we have our grid global module, as you can see. Sorry, I actually closed it. As you can see here, we have rig global, and globals, which is this class. So in globals, we have our base hierarchy, which we first ran this with the asset name and the name of the module. So here, if we can see, if it doesn't get any module name when we're running this, it will give a runtime error, module name not given. So first of all, we are creating all these transforms. So this is tn.create transform. So I have transform class as well. So here, if you can see tn create transform, this has, if we can also give a joint here, and if it doesn't get a joint, it creates basic transforms. So basically, what we are giving here is the name of the transform and the data. So it will get data of the asset name as we use there uh, here. Okay, so we created all these groups. Okay, and then what we're gonna do is we're gonna add message attributes for networks. Okay, so we will say tn.add network attribute. So it will have two network attributes. Like for example, you see tn.add network attribute, rig global, input network. So what we are giving here is giving model name input network. Okay. So when we do that, what it does is, for example, let's select this one. Select this one. 1 second. Yeah. So it create these attributes, message attributes with input and output. So I have just given the name of the attribute here. Okay, so let me just show you this add network attribute that is from 1 second. Hey, this one, yeah, data attribute, add network attribute, yeah, here. So it takes transform name and attribute name. Okay, so attribute name always creates a message attribute, and that's what we are going to connect to that. Okay, so just did this. Okay, this will create all the network attributes plus let me see. Okay, yeah, so this will just create the network attributes, which will be a message attribute. And now what we're gonna do is we're gonna return. Actually, first I'm parenting all these for under global, and then I'm returning this just create this module. Then this next thing we are doing is create network. 1 second. Yeah, it's fine. So create network. So let's see that what it does. So create network is like what. Uh-huh. So create network, this one is like it's just gonna take the module name and it's gonna create the whole network for it. So when we give the module name, it will check that first it will create all these input and output for global, input, output, guide, input, control, skeleton, miscellaneous. Then it will add network attributes to that according to the module name. So we need to give the proper module name here and here. Like the module name needs to be same. Okay, I could even just move this into global base hierarchy, but that's okay, it's not a big deal. So here what I'm going to do is I'm going to create pi node. So all these groups will be created to like make it a PyML node instead of string. Then we're just going to connect the global network attribute to so here we have created this, you see, network attributes. And then I'm just connecting these these nodes to the network attribute. So this is the add network, so it just needs the module name and it creates the network. Okay, let's get back here. Okay, then what we are doing is third is our first module, which is actually global hierarchy. Okay, creating this global control setup and everything like that. So let's check that out 1 second. Yeah, so first of all, here, if the global groups are not provided and it is not equal, like it is different from 5, it needs to be 5. Okay, not enough arguments provided. So because every time we are creating this, we need 5 of these. And here, as you can see, we're taking the row global rig group 0. That will be our module name as well. And here we have our guide group, controls group, skeleton, and miscellaneous. We have not used, so it's showing a little bit gray, but yeah. So after this, what we're gonna do is we're gonna create a pi node of the control. So we have the control class. I have actually shown how I create these controls in another video. I'll link that. But let me just open that control one. That is transforms controllers. That would be controllers. Yeah. So this one is create Bifrost guide. So we have a guide here. Okay. This guide just takes, what are we sending that? Guide name and parent of that. So it can take more stuff like guide position, parent, inherit transform, guide transform. Okay, it returns guide transform. Okay, cool. So we're just passing the name of the guide and the parent. Parent will be guide group, which will be this. Okay, which we have gotten from our base hierarchy. Similarly, for all these, we're just creating the Bifrost guides. Okay, then we have the guide list. Sorry. So we have the guide list here. I've just taken these and created a list. Then we are creating controls here. So we have Bifrost controls here as well, not just guide. And what are we sending to the controls? Second, let's say shape. What type of shape we need? Then the control name, then color of the control. Then the parent, and there is control volume as well. I'm sorry. So there is control volume as well. So the size and shape of this. So I can show you if you, what is actually where is that graph node? Yeah. So all of these, second, these are LOCs. This okay. So if I do one, you see how it's a volume of the control. Let's get back here. Go here. Yep. So that's how I'm creating all these controls and then creating a control list as well. So now what we're gonna do is getting the output and input network nodes. So I have this module in the networks that is find input network. So it just needs module name, and if we need a sub module input network, we will give sub module as well. Okay, if sub module is none, then what it will do is it will just list the connections from module name, whichever which we have given, and type network. So in all in network, if we are getting input network, right? If input is there, then it will return the input network. Similarly, the same we have created for output. If output is in that network, so whatever name we have given, for example, let's get back here. For example, I have given the module name. It will give the global module in and out. Sorry, just had pasta. So here rig guide input network is that. So for guide we have also specified submodule. If there was no submodule, we just needed the input or output network of a main module name, main module base module, which is this one, module structure. I mean this one, this is our base. We just need to give the module name. Or if we need this one as well, the skeleton mod network or input network output network, we need to give module name plus skeleton. Okay, so as you can see here, module name, then sub module name, that will be guides. Okay, so yeah, that's how I can get any input or output network of any module anytime. Okay, so after that what I'm doing is one message drop. Okay, yeah, so for I have this one more module, this thing script, which is add world matrices to output. So when we go here network and see add world matrices to output, what it does it, whatever object is giving, so we have output network here and object is here. So we will so what we will do is we will give two objects here. So let's get back here, the name of the network and the object. So what it will do is it will create all those things, like it will take all the this thing, all the objects which we have given in this loop or just right here, and take its world matrix and inverse world matrix and add attribute to the network. So let's see here. So I'm saying let's erase this. So erase this. Yeah. So what it will do is, so for example, I have given it for the skeleton and we have two skeletons. So it will create attributes on the network output node for world in matrix and world inward matrix of both of these objects. So if we have given both of these objects, it will create world matrix and world inverse matrix on the network output. So we can just directly pass it to here. So I never wanted to create like all these attributes by myself. So we just need the name of the network node and the name of that object. So it will create all these things automatically and just connect them. Okay. So after that, I have the best one of all, that is match network attributes. So what it does it, let's say Rick global output, no, Rick guides. Yep, this one should work. Yeah. So for example, let me what can I do? Let me show you an example. Now let's create a network node which name is A. Okay. Let's name it B and let's name this A. Okay. And let's select, let's go here. I have network and dot match network A to B. So we don't have any attributes on this, right? So when we do match network attributes, we give two networks. Am I correct? Yeah. From and to. And now if I just do this, it will create, you see, so this, it will create all these attributes which were there and create it on the two network as well and connect these as well. So it will query what type of attribute it is and then just directly connect it. So what happens is we don't need to create all these attributes for all these networks, all this stuff which we want to pass to other one. So it always updates. So if we have added some more things in the our network, and we can just match network attribute. Now we have this control list. We are sending all these add metric world matrices to output, the name of the network node and the object. So similarly it does that. Then we are matching network attributes, so from controls to skeleton, and basically we have given this skeleton group and just creating joins here, always taking the last one as the upper one, so it parents it like this and just connected it here. Other than that, we just have our world matrix set up for these controls, so they follow as a parent plus work with guides, always have the guide connections in them as well, and that's it. That's how I'm creating this one. So for the other ones like an arm or big setups and things like that, it just needed some four-fold multimatrices. So I didn't create any Bifrost node. But for the or maybe like these kinds of big setups, we'll create Bifrost node, which will be easier to use, and we will just connect them